Hello folks, welcome to CodeCrucks. In this tutorial, we will construct DFA related to few binary numbers. So let us first understand the number system. The number system could be unary. So as the name suggests, it's a unary number system. So it contains only one symbol to construct any decimal number. So decimal equivalent of 1 would be 10, decimal equivalent of 2 would be 20, decimal equivalent of 3 would be 30. In short, if we have only one symbol to construct any decimal number n, then we have to repeat that number n times. In binary system, we have two digits to construct any number, that is 0 and 1, and using that we can form any decimal, octal, hexadecimal, ASCII or any kind of number. In ternary number system, we have 3 numbers. In octal number system, we have 8 numbers. In decimal, we have 10. And in hexadecimal we have 16. So the base of number could be anything, maybe 2, 3, 4, 5 or anything. But mostly we will be preferring the decimal and the binary because decimals are convenient for human to understand and binary is interpreted well by the computer system. So in this particular tutorial, we will discuss few examples related to binary number and we will construct few DFA for that. Let us understand how to represent the number. If it is a decimal number, then how actually it is constructed. So 1 has a place value 1000, 2 has place value 100, 3 has place value 10 and 4 has place value 1. The leftmost bit or leftmost digit in any number is known as a most significant digit because the place value of that digit is the highest into the number. And the rightmost digit is known as a LSB, least significant bit or least significant digit, because its place value is minimum. So to construct this number, we will pick up the most significant digit and will multiply it by 10. And if there is any subsequent digit, then we have to add into that. So the MSB here is 1. So 1 into 10 plus the following digit is 2. So that makes 12. In 12, the place value of 1 is 10. So we have already multiplied 1 by 10 and place value of 2 is 1. So we have multiplied 2 by 1. Now in original number, 2 follows 3. So we will again multiply 12 by 10 and we add that subsequent number. So this is 1, 2, 3. In second line, we are multiplying 12 by 10. So ultimately we are multiplying 1 and 2 both by 10. But 1 we are already multiplying by 10 in the first line. So now place value of 1 becomes 100 and place value of 2 will become 10 and place value of 3 is 1. Again that 3 followed by 4 in original number. So again we will multiply 123 by 10 and we will add that subsequent number 4 into the original number. So in every iteration we are multiplying the partial number we have created in previous step by 10. So place value of all the numbers in previous step would be incremented by 10. So the digit whose place value was 1 will become now 10. The digit whose place value was 10 will become now 100 and so on. And this is how we can construct the number. If we look at the binary, then in a similar way we can convert binary number into decimal number. The most significant bit is on leftmost side, that is 1. Now base is binary, so we will multiply it by 2. So 1 into 2 plus the subsequent digit which is 0. So we will get 2. Again after 0 there is a subsequent number 1 is present. So we will multiply this 2 by 2 and we will add 1 into that. So that is 5. That one follows the another one. So we will multiply 5 by 2 and we will add that 1 into this. So that is 11. After second one, there is a least significant bit, that is 0, is present. So we will multiply 11 by 2 and we will add that 0 into this number. So we got the 22. Construct a DFA that accepts strings over binary alphabet 0, 1, which when interpreted as binary number is divisible by 2. So we have to construct such a number. We have to construct a DFA such that it accepts all the binary strings which are divisible by 2. So how to determine whether given binary string is divisible by 2 or not? So let us make a simple inspection. On left hand side we have a decimal number, on right hand side we have a binary. So binary equivalent of 0 is 000, binary equivalent of 1 is 001, binary equivalent of 2 is 010, and so on. If we observe carefully, all the even decimal numbers, when we convert it into binary, their last digit is 0 or the least significant digit is 0, which is highlighted in red. And if the last digit is 1 in binary number, then it's a odd number. When any binary string ends in 0, that means it is equivalent to even number, otherwise it is odd number. So let us construct DFA for that. So this would be the language for given definition, that L contains epsilon, then 0, 0, 0, 1, 0, 0, 0, 0, and so on. So any string ending in 0 would be the part of language. So epsilon is a part of language. So initial state would be the final state. So Q0 is the initial state as well as final state. If we read any one, then it is not even number because string would end in 1. So if we have transition of 1 from Q0, we will go to non-final state, which is called Q1. From Q1, we can read 0 or 1. If we read 0, it will go back to Q0 because now string is ending in 0. So it's an even number, so it should be accepted. From Q0, transition of 1 is already out. We will put a self loop of 0 on Q0 so that we can generate all possible numbers. And from Q1, arc of 0 is out, arc of 1 is to be adjusted. So we cannot go from Q1 to Q0 by reading 1. Otherwise, this DFA will accept odd numbers as well. So we can put self loop of 1 on Q1. So this is the DFA for the given problem statement. And the transition table for that looks like this. Q0 is initial state as well as final state. So we are putting arrow symbol and star mark in front of Q0. Let us consider another example. Construct a DFA that accepts strings over 0, 1, which when interpreted as binary number, then it is divisible by 3. So let us first understand what kind of strings are accepted. So when we have a number, decimal number 0, its binary equivalent is 0, 0, 0. So 0 is definitely divisible by any number. Then 1 remainder 3 would be 1, 2 remainder 3 would be 2, and 3 remainder 3 is 0. So that should be accepted. 4 remainder 3 is 1, 5 remainder 3 is 2, should not be accepted, but 6 remainder 3 is 0, so it should be accepted, and so on. So we do not have a clear pattern as we saw in previous example. Here see, if we look at the end symbol, then the string ending in 0 is also valid string, string ending in 1 is also valid string, and similarly strings ending in 0 or 1 are not valid. So we cannot say like if it is ending in 0 then it's always even or odd or it is divisible by 3 like that. So we will construct it step by step. So if we read 0, it should be accepted. Fine. So 0, 0, 0 or any number of zeros are accepted. If we read first one after the any number of zeros, it means we are going to state Q1. So Q1 indicates the remainder of number is 1. So whatever binary number we are creating through iterating Q0 and then we read 1, that string will have equivalent decimal value 1 and 1 remainder 3 is 1. From 3, if we read now 0, then our string would be 1, 0. So from Q0 we are moving to Q1, from Q1 we are moving to Q2. So that string would be 1, 0. 1, 0 is equivalent to decimal 2 and the remainder of 2 with 3 would be 2. So this is how it works. From Q1, if we read 1, then our number would be 0, 1, 1. That is equivalent to decimal 3 and 3 remainder 3 would be 0. So from Q1, if we read 1, we are going back. Next number is 100. So from Q0, we are reading 1, so we are moving to Q1. From Q1, we have already read 0, so we are going to Q2. And if we read 0 from Q2, the next number will become 4, whose remainder is 1. So we will go back into state Q1 because Q1 indicates remainder 1, Q2 indicates remainder 2 and Q0 indicates remainder 0. So remainder would be 0 only when number is divisible by 3. So that is also done. Next transition will be of 1, 0, 1. So from Q0 we read 1, we are moving to Q1. From Q1 we are reading 0, we are going to Q2. If we read 1, then that number would be 5 and 5 remainder 3 is 2. It means we should remain into the same Q2 state. So if we read 1, we are remaining into the Q2 itself. Now this pattern will repeat because all transitions are covered. So if any number is generated in this way, then it will be definitely divisible by 3. And if we look at the table, it looks like this. Let us generalize this fact. So construct a minimal DFA which accepts string of set of strings over 0, 1, 2, which when interpreted as binary number is divisible by 4. So this would be very tricky if we go by that decimal to binary table, but there is an easier way. What we can do is, we have observed the pattern that whenever we have any number which is divisible by some k, then we have to start with Q0, Q1, Q2 up to Qk minus 1. Then we have to keep repeating that pattern. Here we have to put all the states in order. So this is divisible by 4. So there will be 4 states, Q0, Q1, Q2 and Q3. And now same we have to repeat horizontally, but that on right hand side part of the table, Q0, Q1, Q2, Q3. Then again Q0, Q1, Q2, Q3. Again Q0, Q1, Q2, Q3. And this now very easy to convert it into DFA format, right? We have to construct 4 states and appropriate transitions we can construct through this table. You observe the pattern here. It is number divisible by 3. So we have to put 3 states Q0, Q1 and Q2 onto the leftmost column, and under this input 0 and 1 we will repeat that pattern Q0, Q1, Q2, Q0, Q1, Q2. So in case if you are asked to construct a number divisible by 5, then there will be Q0, Q1, Q2, Q3, Q4, 5 states, and same we have to repeat in row, right? So that's quite easy to construct any number divisible by some k. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.